So the title of this video is Composing Functions Using Algebraic Expressions, and so we're going to do the same thing that we did in the last video where we're going to be plugging in one expression's result into another, but this time we're not going to be specific about what we input. Okay, so we're going to actually say, you know what, I'm not going to tell you what x is. I want you to take all of g of x and plug it into f of x. So let's take a look and see what you mean. Okay, so we're going to get an expression at the end instead of getting a number because we're not being specific about x. Okay, so let's come over here and let's go down and see what these look like. Okay, so in this first problem, I'm kind of doing the same thing. I'm saying take x, plug it into g, get that answer, plug that into f. Right, so this looks like it says f of g of x. Okay, now here's where it gets different. I can't actually go to the g function and plug something in. So like g of x is just this. Right? I can't make that look any simpler because I don't know what x is. So when I go to my next step, I'm going to say, okay, you want me to plug in g of x? That's going to be f of this thing, f of x squared plus 2x minus 5. And what this means is go to the f function right here and plug in x squared plus 2x minus 5. So let's see what that looks like. F of x squared plus 2x minus 5 is 3 times x squared plus 2x minus 5, I plugged in, plus 1. Okay, so I'm actually taking the entire g of x expression, plugging that into f, and now we're just simplifying with the algebra. So I'm going to do a distribute, 3x squared plus 6x. Okay, and then I'm going to get a negative 15 from 3 times negative 5, and I can add the 1 to that because now we're out of the parentheses. So it's going to become negative 15 plus 1, which is negative 14. Okay, so when you ask me now what f of g of x is, I'm going to tell you this expression because I took g of x, plugged it in for f, and I came out with the answer. Okay, so let's talk about what the second part of this statement at the top says. Okay, it says the resulting expression will complete the same tasks as the individual composing inputs. So what that means is if I decided to go to my function, okay, and plug in and do it the old-fashioned way, like plugging in a 4 here, for example, and I did f of g of 4. Right? If I went to g and I plugged in a 4 and I got my answer, and I got the number, and then I went over to f and I plugged in that number and I got my final answer, and like let's say it was 20, right? Whatever comes out of this problem. What I'm claiming is that if I went down to this answer and I plugged in the 4 there, I'm going to get the exact same 20 back. Right? So instead of having to take every single number that I want to compose, plugging it into G, getting my answer, plugging it into F, and saying that's the answer, and then starting over again. Oh, you want to know about a new number? Okay, well, I'm going to plug it in here and get my answer, and then go over to F and plug it in again. We don't have to do that. We can compose the algebra expressions and get this thing, and then if you say, oh, you want to know about f of g of x? Okay, I'm just going to plug my answer, my 4 in right here. I'm going to plug in whatever number you want right here instead of having to do it twice. Right, and going through the algebra or the simplifying twice. Okay, so that's the idea, is that this expression 3x squared plus 6x minus 14 will give me the same answer as if I actually manually plugged into g and then plugged into f. Okay, so let's do the other one and see what happens with g of f of x, because we've already said that the order matters when I'm composing. Here I'm taking f of x, right? So let's write it down. We're going to say here, take the g function and plug in f of x. Right, so the g function is this one, right, the x squared function, and I'm saying everywhere that you have an x, I want you to put f of x, which in our case I can go up and say that's 3x plus 1. Okay, so here's what happens here. Let's go to the g function. It says 3x plus 1, okay, squared, right, because that was x squared and I'm plugging in, okay, plus 2 times 3x plus 1, because I'm substituting for x, minus 5. All right, so this one takes a little bit more work. I got some more algebra here, but this isn't something that we don't know how to do. All right, so we're going to say in this case 3x plus 1 squared. Remember that means 3x plus 1 times itself. Okay, so let's just deal with that. We're not going to even write down the rest of the problem. If you were to FOIL this out and multiply all this out, you're going to get 9x squared, and then I'm going to get 3x and another 3x, which is 6x plus 1. So 3x plus 1 squared turns into this, right? Plus, and then let's move on to the next part. I'm going to say, well, 2 times 3 is 6x. 2 times 2 is I'm sorry, 2 times 1 is 2. Okay, and then I have that 5 that's been sitting there by itself. All right, and that's going to be a part of my answer as well. Okay, let me fix my 1. All right, so now I'm just putting these algebra together. It says 9x squared. I have no like terms, so 9x squared. Okay, 6x plus 6x is 12x. Okay, 1 plus 2 is 3. 3 minus 5 is negative 2. So I'm saying this expression, 9x squared plus 12x minus 2, is g of f of x. And if you notice, it's very different than if I had have done it the other way. Right? So again, order matters, really important. Big idea in this video is you can plug an entire expression in, not just a number, and then you just have to use what you know about algebra to simplify those expressions.